Hi, 8th graders. This lesson is going to be covering Chapter 6, Lesson 2, Solving Systems by Substitution. We went over this quickly in class before break, and I want to review this one. So remember, we have our systems, which is our two equations that are going to be given to us, and we're going to solve them by using substitution. Now remember, the solution has to be in ordered pairs, so this is why you have to find the value of x and the value of y. So let's start with two systems of equations. So again, they are bounded by the bracket. You have an equation that could be as simple as y equals 2x, and an additional equation that might be y equals x plus 5. So since we're focusing on substitution in this lesson, we are going to solve for, again, we have to find that ordered pair, our x and our y. So I'm going to substitute, I know what y is for both of these. I know that y is 2x and y is x plus 5. So I can use either one of these equations to substitute because I need to find the value of x. So I'm going to take and substitute as y is 2x. So for this equation, so instead of writing y, I'm going to write 2x. Okay, I'm substituting this y for that value of y of 2x. And then I'm going to finish writing out this equation, x plus 5. So remember what our goal here is to find the value of x. So that means we have to isolate the x. Okay? So I'm going to subtract, because right now x is being added to 5 here, I'm going to subtract x to both sides, leaving me with just x, because 2x minus x is x. Those two cancels out, leaving me with 5. So now I've already found the value of x is 5. So I'm going to write it into my ordered pair. Now I have to find the absolute value of y. Now these are not absolute values of y. These are just an equation saying that, you know, y, whatever y is, it's 2 times something, right? So I'm going to take what I've just figured out here, and then I'm going to plug it back into the equation that I did not use. So since I've already solved for this one, I'm going to plug it back into the second equation. So I'm going to say that y equals 2, instead of times x, we're going to say times 5. Okay, see what I did there? And then y, the value of y is 2 times 5, which y equals 10. So there you have it. I'm claiming that that's my solution, that's my ordered pair. You have to have both x and y. I can also go back and check it. Remember when we said you can check your work by making sure that both equations are true. So if I want to check this one, I can say that 10, because that's what I'm saying is the value of y, equals 2 times x, which is 5. And we know that 10 is 2 times 5, so that first equation does check. The second equation is y, and instead of y I'm going to say that it's 10, is x, which is 5, plus 5. And I know that 5 plus 5 is 10. So therefore I know that I did my work correctly. Now let's suppose that we have an example that makes me work a little bit for it. I might have a system of equations that might be 2x plus y equals 5 and y equals x minus 4. Now it does not necessarily matter which variable I solve for first. If I want to find the value of x or if I want to find the value of y, it doesn't matter which one I go for first. I'm just always looking for the easiest method though. And it also does not matter which equation I start with. But looking at my two equations that are here, I see that they're already given me an equation for y. So I'm choosing to substitute this value of y into this equation. So I'm going to pull this equation, the top one, and I'm going to say that 2x plus, and instead of y, I'm going to substitute this. So I'm going to say plus x minus 4, and then finish it out, equals 5. So I only have the x's in this equation, so that means that I'm going to isolate the x. I'm going to solve for the value of x, because I'm looking again for my x and my y in my ordered pair, my solution. So if I have 2x plus x, we know that gives me 3x. And then if I want to move that negative 4 over to the other side. So how am I going to do that? Remember, we're going to do the opposite. So that's subtracting 4. I'm going to add 4 to both sides. Okay? So that will cancel those out, leaving me with 5 plus 4 is 9. Now you remember the next step. We want to isolate that x. So it's being multiplied. We're going to do the opposite. We're going to divide. So I'm going to divide by 3, both sides by 3, leaving me the value of, because those two will cancel out, x will equal 9 divided by 3 is 3. So now, since I used this equation for the first one, I'm going to take this 3 and plug it into the second equation, since I didn't do that one yet. So now that I know the value of x, which is 3, and I'm going to write that in my ordered pair really quick so I don't forget to do that, I'm going to go back to this equation, and I'm going to say that y is x, which is 3, minus 4. So y is 3 minus 4, which is negative 1. Okay, so now I, of course, want to go back and check my work. So I'm going to go back to the original equations, not any of them that I've changed or altered in any way. So my first equation was the 2 times x plus y should equal 5. So I'm claiming that x is 3. So 2 times 3 plus, that's a negative 1, isn't it? So I have to be careful. I'm going to put that in parentheses so that I don't make a mistake. Should equal 5. Okay, so now I'm going to clean this up a little bit, seeing how I made that nice and messy. So 2 times 3 is 6. My positive and my negative is going to make a negative, isn't it? So it's going to be negative 1 equals 5. So let's check that out and see if it's true. 6 minus 1 equals 5. So there it is. My second equation I'm going to check is y, which is negative 1, equals x, which is 3, minus 4. So I need to finish out that equation. So is negative 1 equivalent to 3 minus 4? Yes, it is. They're both negative 1. So therefore I know that I did it correctly. Negative 1 equals negative 1. Okay? Let's look at another example. Let's suppose that I have 4y minus 5x equals 9. And then I have x minus 4y equals 11 in my system of equations here. So another helpful hint is if you have a variable with a coefficient of 1, I would just go to that one and solve for that one. Normally we're so used to solving for y all the time, but since I don't have a y equals or an x equals, I'm going to go to the equation that has a variable with a coefficient of 1. So I'm going to use this one here, and I'm just going to move this negative 4y to the other side. So I'm going to do x minus 4y equals 11, and I'm going to add 4y to both sides. Okay? So we know what happens here. Those two will cancel out, and leaving me with, and I just like to rewrite it with my my variable in the front is just a preference. So I'm going to say 4y plus 11. Okay, so now I have an equation that's stating what x is. Okay, it's not the value of x, it's just an equation of what x is. So what I'm going to do is I'm going to take this and I'm going to plug it in to this top equation here. So 4y minus 5. Now instead of saying x, I'm going to plug in that value of x, which is 4y plus 11, okay, and equals 9. So now we have to be really careful with this because we have to distribute. Remember, when we're dealing with parentheses, that means multiplication. So I have to be very careful that I distribute that 5 with everything that's in the inside. So I have 4y Okay, now I have negative 5 times 4, which is going to give me negative 20, y. And then negative times a negative makes another negative, and 5 times 11 is 55, equals 9. Okay, now I'm just going to simplify. I'm going to clean this up. So 4 minus 20 will give me, what, negative 16, y. And simultaneously, I'm going to add 55 to both sides. And I don't want to make mistakes, so I always go to my calculator. Smallest mistakes always get us. So 55 plus my 9 will give me 64. And then I'm going to divide by negative 16, right? Because right now that variable is being multiplied. So I'm going to divide both sides by negative 16. So 64 divided by negative 16. And that gives me the value of y equals negative 4. Okay, so I'm almost there. So in my ordered pair, I have the y value, which is negative 4. Now I'm going to come back and solve for my y. So remember I told you that the equation that I work with at the top and originally, which I just did here, I want to go to the other equation to solve in for my variable that I just found. This is a common mistake, so make sure that you do that. So since I worked with this equation for the first round, I have to go to the other equation to solve for my other unknown, which is the x. So the second equation is going to be x minus 4 times y. Now we know what y is. It's negative 4. So I'm going to put that in parentheses to write that out so I don't make any mistakes here. And it equals 11. So now I'm going to do my math here and clean it up. So I have my x. Remember, my negative times my negative, because this is a multiplication here. So it's going to make a positive, isn't it? And then I have 4 times 4, which is 16, equals 11. And then the last thing I have to do here is subtract 16 from both sides, leaving me with x equals, and then I go to my calculator. I know that you want to do mental math all the time, but I always depend on my calculator so I do not make little mistakes. So I have a negative 5. Oops, sorry, I didn't realize I was off the paper there. So my x value is negative 5. So I go back up into my ordered pair, and I have negative 5. Okay, and again, I can go back and check that. So 8th graders, you go back to your original equations, and you can check your work always. So if I do negative, I'm sorry, not negative, 4 times y is negative 4, and minus 5 times negative 5 equals 9. Let's solve this out. So I have negative 16, right? Plus 2 negatives make a positive. So again, my calculator, I am doing negative 16 plus 25, and it does in fact equal 9. So my first equation does check. And then remember, they both have to satisfy the solution. So I'm going to move my paper down so you can see what I'm doing. I'm going to the second equation now. And x is negative 5 minus 4 times negative 4. And we're claiming that it will equal 11. So let's follow through on our math. So negative 5 is not being multiplied with anything, so that's just going to drop right down. These two are the ones that are being multiplied, right? So we have a negative times a negative, which is going to make a positive, and 4 times 4 is 16, and then equals 11. So finally, negative 5 plus 16, we know, is 11. And that one checks. So I know that I did my substitution correctly, simply by checking my work. So my ordered pair, plugged back into the original equations, check out to be true. Okay, so that's all you have to do for substitution. So recap what I did. I solved for either variable, either the x or the y, moving everything else to the other side. So I shouldn't say solved for the variable, I isolated one of the variables to get an equation on the opposite side of the equal sign. Then I substituted it into one of the equations. I picked either one, it didn't matter originally. Then when I found the value of x or y, in this case y, I took that value of y and I went back up to the other equation that I did not substitute in, and then I solved out for that one. So these ones take a little bit of practice. Again, the name of it, substitution, for the reason that you are substituting. All right, you're substituting to solve for your unknown variables. So practice a couple of those and see how well you do. Remember, to be successful in this is to isolate the x or y first, step one, then substitute it into one of the original equations, find your value of the x or y, depends on what you're doing, and then you take that value of your x or y and you go back into the second equation, and then you will solve for your other unknown variable. All right, again, it takes a little bit of practice. I know you can do it. All right, keep in touch. Bye.